Today we're going to look at properties of exponents. You should be familiar with all the rules that we're going to go over. So we're going to get some rust off and give you some practice. So for our first example, we're going to start off with x squared times x cubed. We all know that x squared is x times x, and x cubed is x times x times x. So when we put this together, our answer should be x to the fifth. Most of us think that when we're multiplying powers of the same base, the exponents will just get added. So a general rule would be, if we have x to the a times x to the b, our answer will be x to the a plus b. Following closely behind this rule is the idea of what do we do when we have a power raised to a power. For example, x squared cubed. Well, we all know x squared cubed means x squared times x squared times x squared. But by the rule that we just learned or reviewed, powers of the same base when multiplied end up with the exponents being added, so that now we have x to the sixth. Again, if we do a power to a power, we could see our new rule is that the new exponent will be the original exponents multiplied. So with that said, we could say that when we have x raised to the a raised to the b, we're going to get x to the ab. An example of a problem like this, I can give you something like 3y to the sixth squared times x to the fifth y squared z. Now the first thing I would take care of is the power to a power. So I'm going to take care of this whole term in parentheses squared. And I'm going to see that 3 squared is 9, y to the 6th squared is y to the 12th. Now I'm going to multiply that by x to the 5th, y squared z. Now when I do that, I'm going to have 9 times 1, y to the 12th times y squared is y to the 14th. I notice I just left out the x, so we'll put in the x to the 5th z. So that looks right, y to the 14th, x to the 5th z. I think in a perfect world I would have just put the x first. Now you're going to stop the video and you're going to give it a shot and do one on your own. What we're going to do now is look at what happens when we divide. So right now we're going to start with x, let's say to the 4th divided by x squared. We could see that x to the 4th is just x times x times x times x over x squared is x times x, and by canceling common factors we see the answer is x squared. A lot of you say, well, hey, why couldn't you use the rule I know in the beginning, which is that when you have powers of the same base and you're dividing, then the exponents end up being subtracted. This leads to some neat things. For example, if you have x to the a divided by x to the a, we now know that this is the same as x to the 0, because a minus a is 0, but we also know that when we divide anything by itself, like x to the a times x to the, divided by x to the a, we have to get 1. So this leads us to the conclusion that anything raised to the 0 power is 1. Another neat kind of, I guess, corollary of this is that we can get what the idea of a negative exponent is. For example, if I had x squared divided by x to the 4th, we know that the x squared on top means x times x. The x to the 4th on the bottom is the product of 4 x's. We know canceling out common factors, we are now left with 1 over x squared. But we also know that the rule is to subtract the exponents. So when we do the 2 minus the 4, that's the same as x to the negative 2, which in the past you've generalized as if you have x to the negative a, that's the same as 1 over x to the a. Last thing I want to mention is that if you were, say, to have x over y cubed, we can think of this as x over y times x over y times x over y, which is the same as x cubed y cubed, which basically means that when you have, let's say, x to the a, or let's make this, I'm going to make a correction here. When we have x over y to the a, it's the same as the numerator raised to the a and the denominator raised to the a. So that's another nice rule that we can see. With this said, let's try another example, one with, say, a division. And I'm thinking about, let's do the following. Let's do, okay, let's go for the gusto. I'm going to do this in a different color. 2h cubed j to the negative 3 k to the 4th over 3jk. Now, there's nothing we can do with the 2 and the 3, so they're going to stay. There's no other h, so the h to the cube stays. Now, we're going to work with dividing a j by a j. We have j to the negative 3 divided by a j to the 1. When we subtract exponents, that's j to the negative 4. If you're a negative 4 exponent in the numerator, that basically means you're a positive to the 4th in the denominator. And now when we do k to the 4th divided by k, subtracting the exponents, we get k to the 3rd. So this would be our final answer. In the problems that you do in the next section, what I want you to try to do is leave no negative exponents. So if you get a negative exponent, I want you to rewrite it without a negative exponent. So in this case, instead of writing j to the negative 4 in the numerator, I wrote it as a j to the 4th in the denominator. I hope this took some of the rust off your rules. I want you to try a couple of problems. I'll check them and we'll see how it goes. All the best.